The next topic deals with pre-attentive processing, and the idea here is that we have our nerves in our eye, our uh, sensors, and then they translate. We have a whole visual nerve that goes towards the brain, but before it reaches our conscious mind, if it gets processed, there's some parts of our brain that go and process it, and we don't necessarily control those. Uh, or we don't necessarily have to control those. They happen whether we want it or not, and they happen without us paying attention. So by attention, really another buzzword for it will be our cognitive processing, cognitive system, where we think what we need to do. We think what we're seeing, we process what we've seen so far, things like those. So uh, psychologists and people who study this, they kind of narrow it down to say that if it happens in less than 250 milliseconds, it's basically not enough time for the signal to reach our cognitive system. Uh, and it's kind of, that's our eye movement. Many times our eyes move without you controlling it, without us controlling it voluntarily. Sometimes we do, we turn our head, but many times the eyes keep moving left and right. And again, something like that happens because, at least that's the theory. Being psychology, there's probably about 2 or 3 theories on everything. But that's one theory that says that this happens because this pre-attentive process. So before we get before that gets to be taught by us, we kind of process information. So if we could do that, visualizations would be well, fast, but not necessarily that's the issue. It's just without taking our attention, then we can do a lot more. We can focus our attention on something else because this pre-attentive stuff happens almost without us thinking about it. And there's maybe 3 main areas that, and I wrote it like that, take in the visualization context, but really what gets our attention is something out of the ordinary, like a bright light, a red dot in the middle of a gray ocean. Things like those, they get our attention. And so basically, if information is important, maybe we just allocate something, some visual thing that is different. So this way, pre-attentively, we see that something important is happening or where it is happening, things like those. The other thing is we can determine boundaries of regions pretty quickly. So we see where the sky ends and the earth begins. We see where the big bear begins and the forest ends around the bear. So we can guesstimate that and pretty quickly determine that. So boundaries between regions that are different. And the other thing that may happen pre-attentively may be kind of estimation. We can see that there are more of these type than of the other type. Not very precise. I mean, for data analytics, I still have to use my cognitive system, but maybe just overall, I can get, while I'm doing data analytics, I may be able to even understand something on the counting, that there are not many of these things that I'm analyzing right now. So there's a whole, and one more thing I want to point out, it's not on the slides, but it's not an all or nothing. So there are things in our visual, even right now, there are some things that will catch my attention, looking outside, looking at the monitor in your room. And there are things that will need me to read. So if I want to read the words estimation, I need to read them. So I kind of need to move my eye and go there and read them. It's not something that pops up to me, oh, there's an estimation word. The estimation word is on this slide. Okay, so that in this sense, I don't think reading is pre-attentive. I'll get back to it in a second at the end of this. So I will share my screen. I have a website that I can show you. I already loaded it up. It's on the slides. So it's from North Carolina State University. And here is just the map. Well, it's maybe pre-attentive, maybe not. You can kind of see this red thing popping up at you. There's a rule they made this map. Here's explaining it. I don't think it's that important for the pre-attentive part, but I think he has a lot of in here that is important. So here is something that we can do pre-attentively, determine that there's a red dot in the middle of all the blue ones. Or determine that there is none. Both of them actually can happen. So even if we see this just for a fraction of a second, we'll be able to do that. Over here, it's not as easy, but you can still, your visual system will be attracted to this red dot in the middle of red squares. So it's not as powerful as color, but different shape will pop up at us. Here, you kind of have to search for the red dot. So I don't know if there is a red dot here. In order to determine that, I kind of need to go through the visualization, and there is one here that I see. So especially the negative part is going to be really harder to do. The positive, if I happen to, when I open my eyes, I'm in this area, I'll see it. But the negative part, I won't know for sure until I scan everything. So what happens here, they kind of they glued this with this one, so they took the two and put them together, color and shape, so it didn't work that well. And I have this thing, again, if you pull up the slides, if you're at home and you want to try it, I don't know how precise this is inside of a browser. Not sure if it's exactly 200 milliseconds. I'll make it a little bit. Oh, there's nothing in between. So, well, let's try it at 200. So this is just color. We can do about 6 of these. Elements, I leave it at 25, their default. So you would see, all you have to do is tell me if it's positive or absent or present. The red dot. Absent, 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 present, present, present. So that's, were there 6 trials? Yeah, 3. Just so randomly they pick. But you see how without staying for too long, you kind of see it right there. We can try the same thing with shape only. So this is going to be all red, but some of them are squares, some of them are circles. Present, absent, present, absent. Oh, there's present, absent, absent. So I messed up one. It's not as easy. People are going to make more mistakes, but on this one is almost like if I don't see it, I'm going to say absent. So I didn't see it on that one. And then finally, we join the two, and maybe again, this is an illustration of why visualization is not modularizable, if that's a word, modular. If I have some that works, something else that kind of works, put the two together and they stop working. So let's see. I don't know. Absent. No, it was present. Absent. Present. Absent. Absent. So it's a little bit harder, and it gets harder and harder. So that's one thing. I like that they have this. We can try it for yourself. You know, if you want to make it, you know, increase the time and put more of this. And it's a relatively small visual area. You know, it gets bigger, it's going to be harder. But they've done. There's people who have done studies and kind of tried to figure out what works and what doesn't. Again, nothing is perfect, but you can kind of see how that works. Other things, and they also mentioned the papers here, other things that are pre-attentive or have a high degree of, you know, it's the blob orientation. We're going to see it. One of them is longer than the other, the rest. Closure, one of them is closed, the other are open. Size, again, one of them is bigger than the others. Curvature, one of them is curved, the others are straight. Density, you kind of see, this is also estimation. You kind of see there are more points here than the rest. And also kind of boundary, you see a boundary. You see there's something as an area there. Estimation, again, if there, you can see there's a lot more that are, well, not a lot, that there's more that are horizontal than slanted there. Color, obviously we've done that. This is intensity, so the color is slightly different. It's still blue, but it's not as intense. Intersection, notice that all of these shapes are composed of the same thing, one horizontal, one vertical bar. But all of them are kind of form a shape of L, except that one that's a cross, so we kind of pops up. Same thing here, except that it's a T versus an L, so it terminates. This one here is different. The light, the 3D depth shows up differently in here, so it will pop up. So these are flickering, so we'll see them. One of them is moving in a different direction than the others. One of them is moving faster, and then here one is the shadow of this one is from on the other side than the others. So one is to the right, this one is to the left. This is in 3D, and I'm not sure if artistic property what shows up here. I don't know. That's something that Healy is the author of the page. Now on boundaries, we can see boundary based on color. It's here. There's also a boundary right here on the left side of that boundaries. All squares are blue or circles are red. Right here on the right side, all squares are red. It's the opposite, and circles are blue. It's kind of, and it's not that easy to see. You kind of have to pay attention to see it. And there's some theory here. Again, these are continuous or not. This one is different. So this area, well, which one? I don't know. There's a bunch of S's right here. Various interpretations and theories, not necessarily going to spend time on them. And here is the game here. They have another of these simulators. All we need to pick out is whether the boundary is horizontal or vertical. And it's going to be based on color, based on shape, or a combination. Kind of same thing. 6 seems to be a good number. And so horizontal or vertical? Vertical, horizontal, horizontal, horizontal. It takes me longer to say it. Vertical and vertical. If we want to go to shape alone, horizontal, vertical, vertical, horizontal, horizontal, and vertical. And then interference, we just mix the two. I'm not sure if it matters what else I select there. Horizontal, it's still there, horizontal. The shape, the colors are mixed, but the shapes are the same, so it's not that hard, I think. Let's see if we get something different if I do this. Now, oh yeah, that's even easier. So this is, I would say that the other one is the worst when we do interference on shape. But still doable. I can detect kind of where the border area is. Some of the things here, I already have that one on my slides, various kind of processing, but I think that's it with the with this demonstration. Let me share my slides again. Keep clicking on them. Oh, and I have this, before I go, I have this pre-attentive 3D that doesn't show up in my slides properly. This thing here. It shows black when I go to the files. It didn't import properly. The thing here is that all the shapes here I made out of three things. There's a white diamond, and then these two, one gray and one black parallelogram. It's just the way they are put together, it creates a cube on the visualization on the right, sorry, left. And here it's not 3D interpretable on the right. And you can see these are different. It's kind of harder to see, but there's 4 of them here that are different. So this pops up. You probably need to scan it a little bit to get to it. Okay, so that here is how it looks like on the slides. That's why I wanted to talk about it. So more or less, I'm in conclusion, this pre-attentive processing, it happens pretty quickly. So it will allow people to understand the visualization that really moves fast or pops up at them without having to spend a lot of time analyzing. It's not everything in a visualization may be there. You may be able to, if you look at a visualization of a map, for example, you see the boundary between land and sea. If you want to see more detail, that it's obvious. And if you need more detail, you kind of recognize a shape in there, like the shape of Europe. And then you kind of know where France is, then you move there and start analyzing. So it helps you orient yourself. You're not completely lost. That's kind of, it's not all or nothing. It's like the degree to which it's visible. 3D kind of helps us because we process the world in 3D. Our world is 3D, but our visual system, and I take the time here to say that it is, and maybe I'll say it even later, our visual system is really two-dimensional. I've run into this. I had a colleague from I think more like geology, applied science. They were using ground penetrating radar to look underground for pipes and to see where the water, if there's a pipe leak, like you have pipes that are buried underground. And that thing was, and the other thing you can consider, other than that, consider an MRI. An MRI is three-dimensional. And they wanted to see everything, and I had to tell them, you cannot see everything. Why? Because if I show you each and every point in 3D, if one point, the only thing that you see is the surface at the top. You don't see inside, unless I make it transparent, and that's going to be weird. In other words, if you take your head and put it in the sand, you're not going to see through the sand. So our visual system relies on the fact that air is transparent, and we see all the way till we hit the surface, and that's what we detect, the surface, not the volume. Maybe we guesstimate the volume, and I'm not sure we're that good at guesstimating volumes. But that's kind of our visual system. That's why, I mean, our visual system is not three-dimensional. We see the shape, the shape is not flat. It may envelop it. It's like a piece of cloth that falls under something. We see that shape and colors for it. But anyway, if the visualization has some 3D features, sometimes it's good. Other people actually in the visualization community say that 3D is not good. There's a big split right in the middle there. Feature created by smaller shapes, like this one that I can show you again, can help, if may be important. And then on text, I don't think text is pre-attentive. And I had a big discussion at one semester. There was a big, not me, I mean the whole class, had a big discussion on whether text is pre-attentive. And I think that text is not, you have to read it, but certain words are pre-attentive. In other words, we detect the shape of, words like of has a certain shape that we recognize. We don't have to read each and every letter. A shape like the, cat, whatever. And they have a certain shape when they're written, and I think we can recognize that pre-attentively. I agree with that. But if you want to read something, you probably have to read, pay attention. And my best example there was figure out if the word is altitude or attitude. That requires very close reading to figure out. They have the same shape. So if words have the same shape, the same boundaries, then maybe it becomes harder. We have to read them. So I think text is typically not pre-attentive, especially in precise text. But some pieces of text we recognize pre-attentively just because the shape of the words.